Because
remember, when it's the bottom number here, the reason I get these negatives is it's minus this value. This negative is still sitting out here. So it's going to be minus this lower value and minus that lower value. But then this negative will come through here and make those pluses. So you get 2 root 2 units squared.
is it just because that's the part that's below the x-axis?
That plays into it. There's a little bit of symmetry to what's going on.
Can you explain that again?
Pull this down. Pull this down. Okay, get all the little symbols.
Yeah. Gotcha.
Alright. And we're really kind of dealing with this side, right?
Yes. The first time makes sense.
Okay. Remember, when I plug these things in, the numbers that are on the top are here first.
Yes.
Then we subtract, plugging in the numbers on the bottom.
Okay, yeah. Okay, great.
And so then that's going to give me the pluses and minuses I get there. Go ahead.
No, I'm still confused because, like, I thought it's supposed to be the top curve minus the bottom curve, but why then up there in the middle is there an addition sign?
Okay. Let me ask you this.
Oh, because we're
This
adding,
first one is for this region in
okay,
red.
now I understand because we're doing the top minus the bottom. Okay, and then adding. Okay.
Got it?
I got it.
Good. Now let's add that next layer of fun.
Woo.
Some of our functions are not defined as functions of x. Some of our functions are defined as functions of y. So you have f of y and a g of y. Let's see, how do I want to do this one?
It's just the same thing, you just tilt that.
I know, I'm just trying to think of a couple of functions I want to use. Let's do 3 minus y, and let's do y squared. Okay, now for the fun part.
It's going to be...
We gotta graph them.
That's
Like,
flip a page. Can you give us
I can do the y squared one.
Are we just...
Well, what's this one look like?
Wait, the y squared? Oh, yeah.
Yeah, it's just back here.
It's a parabola on its side, right? So, what does that one look like? I hope it beats.
Yeah, just some guy.
Okay, when y is 0, x is 3. So 1, 2, 3. So that's going to be there. Yeah, it ought to meet somehow. When y is 3, x is 0, right?
Yeah.
So we've got the line that goes through kind of like that. Are we going to have points of intersection? Numerically speaking, which numerical value am I most concerned about from this point of intersection? The x number or the y number? How many think I know about the x number for the point of intersection? How many think I should know about the y number for the point of intersection? How many really aren't sure? There's the hands. Okay. When it is functions of y, I want to know about y values of intersection. Now, at this stage, all I plan to do here is set this thing up. I don't plan for us to solve it necessarily, because once we get to the solving point, it's not too bad. Okay. Let us call this point down here an A, and let's call this point up here a B. I don't know what they are, but we'll call them that. What was the old idea in the x functions? The idea of finding the area between the curves. What was the concept?
You subtract the one that's lower.
So top minus bottom. Okay, from whatever this point is over here, it's pretty clear that this line is above the parabola. But what happens from this point going this way? There's a parabola piece over a parabola piece, right? Uh-oh. That's going to be a little complicated. So here's what we do when we're dealing with functions of y. We are going to say area is equal to right curve minus left curve to get the area between the curves. And that's another really important concept for the whole chapter. Right minus left. If you remember top minus bottom and right minus left, it'll be pretty good for you on the chapter.
Wait, the whole chapter or the half chapter?
No, the whole chapter. Yeah, that is important to establish. So then we have the area is equal to the integral from a to b of the right curve being 3 minus y minus y squared dy. That's what we evaluate. Then you just got to find the a and the b.
How do you know which one's right and which one's
Yeah.
Okay. In the region that I'm working for area, which is right in here, which curve is to the right of that region? Doesn't this line describe that right-hand boundary? And then this parabola describes the left-hand boundary? That's how I know right minus left. But I need to be able to see the picture to do that.
So we do right minus left on the y.
On the y ones, yes. Functions of y. Any other good questions?